Bismillahirrahmanirrahim. Assalamu alaikum everyone. The topic of my presentation is Massive MIMO in 5G. So we will start from the basics like what is MIMO and Massive MIMO, and then we will go forward. So talking about the basic wireless communication system, we have a transmitter and a receiver and a wireless channel as shown below. Now the transmitter has data which is to be sent at the receiver end, and the data can be a web page, phone call, messages or anything. Now there can be many different types of hurdles in our system which can disturb the communication between transmitter and receiver as seen below. To solve this problem and have a high data rate, we have a MIMO wireless network, basically multiple input multiple output wireless network with multiple antennas at both the transmitter and the receiver ends. A MIMO multiple input multiple output system has high data rate and increased reliability as it takes advantage of the multipaths that exist between transmitter and the receiver. Multiple reflected signals at receiver side gives more samples of what was the original signal, but in CISO, which is basically single input single output system, we have only one antenna to receive signals, so multiple reflected signals can create a problem at receiver side for a single input single output CISO system. So what is Massive MIMO then? Massive MIMO wireless communication refers to the idea of equipping cellular base stations with very large number of antennas to provide better throughput and better spectrum efficiency. It can have hundreds of antennas at the base station and multiple antennas at the receiver side too. Now in earlier systems we had CISO system, basically single input single output system, refers to the wireless communication system in which one antenna is used at the source and one antenna is used at the destination receiver. CISO is the simplest antenna technology. The only advantage of CISO system is the simplicity. CISO requires no processing in terms of various forms of diversity that may be used. However, the CISO channel is limited to its performance too. Interference and fading will impact the system more than a MIMO system using some form of diversity. And talking about the 4x4 MIMO, in which 4 antennas are used at transmitter and receiver, uses 4 antennas to establish up to 4 streams of data with the receiving device. Compared to ordinary single input and single output system, the 4x4 MIMO offers up to 400% increase in throughput. Now there is not currently a definitive number of antennas that define the difference between MIMO and Massive MIMO, but it is widely accepted that 8x8 antennas or more, the technology becomes what is known as a Massive MIMO. Now here are the different advantages of Massive MIMO. First of all, capacity increase. The benefit of Massive MIMO comes from increasing network capacity without using additional spectrum or base stations. For 5G, Massive MIMO is a critical component to enabling broader signal coverage. Spectral efficiency. 5G Massive MIMO is able to leverage its antenna array to focus beams down to individual users. This allows us to achieve spectral efficiencies 10 times better than that of system used for 4G. Energy efficiency. In Massive MIMO, antennas can be used in conjunction to increase the gain of transmitted signal. This means they radiate less power when transmitting data, making it a more energy efficient system. Stronger signal and reduction of interference for better coverage. Due to beamforming in Massive MIMO, it provides accurate and narrow beam aiming of the signal, which reduces interference and improves signal quality, especially at the cell edge. Beamforming allows for expanded reach of the cell compared to traditional antennas. So now we will see what is 5G and why we need 5G. Now the world mobile phone connections are increasing day by day. As we can see, in just 2014 the unique mobile users were 3.6 billion plus, and now currently the numbers are enormous, like 5.20 billion plus. So we need more capacity and efficient system to keep the people connected to each other. Furthermore, for IoT systems or smart cities, we need more devices to be connected to each other for communication, for which we need a better wireless communication system. 5G enables a new kind of network that is designed to connect virtually everyone and everything together, including machines, objects, and devices. 5G will be able to handle 1,000 times more traffic than today's network, and it will be 10 times faster than 4G. 5G wireless technology is meant to deliver higher multi-Gbps, peak data speeds, ultra-low latency, more reliability, massive network capacity, and increased availability, and a more uniform user experience to more users. So it is very important for the coming future. Now here we will see what changes 5G can bring for the future. Enhanced mobile broadband. In addition to making our smartphones better, 5G mobile technology can usher in new immersive experiences such as virtual reality and augmented reality with faster real-time response with more uniform data rates, low latency, and lower cost per bit. Mission critical communications. 5G can enable new services that can transform industries with ultra-reliable, available, low-latency links like remote control of critical infrastructures, vehicle, and medical procedures. Massive IoT. 5G is meant to seamlessly connect a massive number of embedded sensors in virtually everything through the ability to scale down in data rates, power, and mobility, providing extremely lean and low-cost connectivity solutions. Now we will see the comparison between 4G and 5G, and we'll see that why and how much 5G is better as compared to 4G. With respect to high bandwidth, 4G could only muster about 200 Mbps of data throughput on a good day in perfect conditions, but 5G can handle about 1000 Mbps, basically 1 Gbps or more. Low latency. 4G suffers from around 100 milliseconds response delay on average. 5G response time can be as fast as 1 millisecond, which is very fast as compared to 4G. Dense connections. A comparison between 4G and 5G can be made with respect to the connectivity of devices, and 4G can only connect to about 1/10 the amount of devices as 5G can. Now here are the different techniques we will see which can be used for the 5G wireless communication system, like small cell technology, full duplex, millimeter waves, cognitive radio, and massive MIMO. Small cell technology. Small cell make use of low power, short range wireless transmission systems that cover small geographical areas. Small cells are uniquely capable of handling high data rates for mobile broadband and consumers, and for IoT and high densities of low speed, low power devices. Now there are the different types of small cells which can be used with respect to their power and their range, like femtocells, picocells, and microcells. Full duplex. In 4G systems, both frequency division duplex and time division duplex require two separate channels to realize orthogonal transmission and reception, which wastes half of radio resources. Full duplex can double the spectrum efficiency by simultaneous transmission and reception on the same frequency and time source. In addition, full duplex also helps to reduce packet delay and improve network efficiency. Due to double spectrum efficiency, full duplex is widely considered as one of the promising techniques in 5G systems. Millimeter waves. Now millimeter wave band is the band which have never been used for cellular communications before, but it is of great importance for 5G as more and more devices need to be connected for communication for increasing capacity. Millimeter waves brings many performance benefits, and it is an essential part of the 5G systems. It provides mobile operators with a critical competitive advantage to address massive increases in mobile data demand. Cognitive radio. Now different parts of the radio spectrum have been defined to be used by different wireless technologies. As a result, some frequency bands are very crowded, like the GSM one as we can see below, while some others are hardly used frequency bands like the military bands, which result in a spectral inefficiency. Now utilization of cognitive radio for the 5th generation communication technology is a major advancement for getting a higher bandwidth in a cellular communication network. Now cognitive radio is a technology that reduces spectral inefficiency with software defined radio SDR. With SDR, the base station is able to sense the under and overutilized parts of the spectrum, then it redistributes the transmission to ensure that the spectrum is more efficiently used. For example, here SDR enables the GSM base station to ask the military or TV base station that if it can share the radio spectrum with it without much interference. If this is permitted, then some of the TV or military spectrum is used, reducing the spectral inefficiency. Massive MIMO. Massive MIMO does not have a specific meaning other than having more antennas than what is currently used in mobile networks. With massive MIMO comes beamforming, which allows for the focusing of the radio signal on areas of demand on specific user devices. Now, it improves spectral efficiency mainly because the advanced beamforming has to generate greater signal accuracy, including better call quality at the cell edge. Beamforming refers to the function of smart antennas which control the properties of the electromagnetic wave radiation pattern of an array antenna by aligning the amplitude and phase of transmitting or receiving signal in array antenna elements, thus increasing the cell thus increasing the array antenna gain in the intended angle of direction and at the same time suppressing gain in other angular directions where interference signals would result. Beamforming techniques have evolved from two-dimensional 2D techniques to three-dimensional beamforming techniques, not only covering horizontal but also vertical, such as required for high-rise buildings. And this is why 3D beamforming technique is more attractive in massive MIMO wireless communication, owing to the beneficial capability of controlling the strength of radiation field energy in different directions. Now, and here we can see the comparison between the efficiency of 3D and 2D beamforming with respect to different numbers of antennas as shown. Here M represents the number of antenna, and number of antennas are much greater than single antenna user K, and as we can see that the efficiency of 3D beamforming with higher number of antennas is greater than 3D beamforming with lesser number of antennas, and of course much more greater than 2D beamforming. Now, further beamforming techniques can be divided into two main types, basically a switched beamforming and adaptive beamforming. Now, a switched beam system depends on a fixed beamforming network that yields established predefined beams. In this way, we don't focus on individual users or devices, but a fixed beam is focused on in a direction and different devices can come under that beam, which can result in interference, of course. So, a better technique for beamforming from switched beamforming is adaptive beamforming. Now, adaptive beamforming presupposes that base station updates the localization of the mobile station. However, accurate localization is not an easy task since a big number of simultaneous mobile users can overload the process. So, of course, there are complexity in adaptive beamforming too. And here is the comparison between switched beamforming and adaptive beamforming techniques. Adaptive beamforming has major advantage over fixed beamforming with respect to coverage and capacity and interference rejection, but it is complex and expensive system as compared to fixed beamforming. Now, there are different algorithms for adaptive beamforming like least mean square LMS, normalized least mean square NLMS, recursive least square RLS, and sample matrix inversion SMI. And the most efficient algorithm is considered the least mean square algorithm, so we will see this here. For time varying signal environment, a recursive update of the system is needed to track a moving mobile user so that the special filtering beam will adaptively steer to the target, then resulting in optimal transmission and reception of the desired signal. Now consider different antennas in a massive MIMO antenna array, and the radiation pattern is shown with main desired lobe and the side lobes or undesired signal, and we multiply them with beamformer weights, and then we add all the components and we get the signal output. And with respect to this signal output, the radiation pattern is adjusted for adaptive beamforming. If the user moves, the main lobe also changes as per the user moves, and now in this way we get connected to our desired user for the communication. The functionality of the LMS algorithm is represented as follows. The output of the antenna array can be expressed as YT, which is given by equation 1, where ST denotes the desired signal arriving at angle phi naught and UIT denotes interfering signal arriving at angle phi I, and NT is the additive noise. Now in equation 2 we have W into N plus 1, which is basically updated weight, and Wn is the previous weight, and mu is step size and controls the convergence characteristic of LMS. Now in equation 3 we can observe that E square N is mean square error between the beamformer output Y and the reference signal D. And here are some simulation results which were given in the paper to show the variation in beamforming pattern with change in number of antenna elements. Now as the number of antenna elements change from 16 to 64 to 256 and finally to 1024 from top left to bottom right, we see that the beam gain of signal of interest increases while decreasing the effect of signal not of interest. Conclusion. Now, Massive MIMO can offer enhanced broadband services in the future and more. 5G networks are expected to support a great variety of wireless services in areas ranging from healthcare to smart homes and smart cities, manufacturing, and many others. Massive MIMO technology can be tailored to support a massive number of massive machine type communication devices. Also, it is an excellent candidate to realize ultra reliable communication as it can establish very robust physical links. And here are the different papers which were studied for the presentation of Massive MIMO in 5G. Thank you.